Statistics is the interpretation, representation, and organization of data. In other words, it is a mathematical discipline to collect, summarize data. A statistic is simply defined as the study and manipulation of data. Statistics deals with the analysis and computation of numerical data. Mathematically, statistics is defined as the set of equations which are used to analyze things. According to Merriam-Webster Dictionary, statistics is defined as classified facts representing the conditions of a people and state, especially the facts that can be stated in number or any other tabular or classified arrangement. And according to statistician Sir Arthur Leon Bowley, statistic is defined as numerical statement of facts in any department of inquiry placed in relation to each other. Example of statistics are basic of statistics and mathematical statistics. The basic of statistics include the measure of central tendency and the measure of dispersion, where the central tendencies are mean, median, and mode, and dispersion comprise variance and standard deviation. Mathematical statistics is the application of mathematics to statistics, which was initially conceived as the science of the state, the collection and analysis of facts about the country, its economy and military population, and so forth. Methods in statistics involve collecting, summarizing, analyzing, and interpreting variable numerical data. Here some of the methods are provided below: data collection, data summarization, statistical analysis. Statistics have huge application across various fields in mathematics as well as in real life. Some of the applications of statistics are applied statistics, theoretical statistics, and mathematical statistics. Machine learning and data mining, statistics in society, statistical computing, and statistics applied to the mathematics of the arts. Summary statistics is a type of descriptive statistics which is used to summarize the set of observation with large information as simply as possible. A statistician used to describe the observation by finding the measures of central tendency, statistical dispersion, statistical dependence, and the shape of the distribution. Statistics is applicable in mathematics because it uses probability theory to generalize the collected sample data. It also helps to characterize the likelihood where the generalization of data are accurate. The purpose of statistics is to make us learn to utilize a restricted sample to make accurate determinations about a more prominent populace. The utilization of tables, diagrams, and graphs assumes a crucial part in introducing the information being utilized to reach these determinations. Statistics is important in real life because it encourages us to utilize legitimate strategies to gather the information, utilize the right examination, and successfully present the outcomes. Measurements is a significant cycles behind how we make disclosure in science, settle on choices dependent on information, and make forecasts. The two branches in statistics are descriptive statistics and inferential statistics. In the case of descriptive statistics, the data or collection of data is described in summary, but in the case of inferential statistics, it is used to explain the descriptive one. Both these types has been used on large scale. Types of descriptive statistics are the distribution, the central tendency, and the variability or dispersion. The distribution concerns the frequency of each value. The central tendency concerns the average of the values. The variability or dispersion concerns how spread out the values are. You can apply this to assess only one variable at a time in an bivariate analysis or to compare two or more in bivariate and multivariable analysis. In tables or graphs, you can summarize the frequency of every possible value of a variable in numbers or percentages. This is called the frequency distribution. Measures of central tendency estimates the center or average of a dataset. The mean, median, and mode are three ways of finding the average. The mean or M is the most commonly used method for finding the average. To find the mean, simply add up all response values and divide the sum by the total number of responses. The total number of responses or observation is called N. The median is the value that's exactly in the middle of a dataset. To find the median, order each response value from the smallest to the biggest. Then the median is the number in the middle. If there are two numbers in the middle, find their mean. The mode is simply the most popular or most frequent response value. A dataset can have no mode, one mode, or more than one mode. To find the mode, order your dataset from lowest to highest and find the response that occurs most frequently. Measure of variability is also known as measure of dispersion and used to describe variability in a sample or population. In statistics, there are three common measures of variability as shown below: range, standard deviation, and variance. Range, it is given measure of how to spread apart values in sample set or data set. While standard deviation, S or SD, is the average amount of variability in your data set, and variance is simply describes how much a random variable differs from expected value, and it is also computed as square of deviation. Inferential statistics makes inference and prediction about population based on a sample of data taken from population. It is simply used for explaining meaning of descriptive stats. It is simply used to analyze, interpret result, and draw conclusion. Sampling error and inferential statistics. This creates sampling error, which is the difference between the true population values called parameters and the measured sample values called statistics. Sampling error arises anytime you use a sample, even if your sample is random and unbiased. For this reason, there is always some uncertainty in inferential statistics. However, using probability sampling method reduces this uncertainty. Estimating population parameters from sample statistics. The characteristics of sample and population are described by numbers called statistics and parameter. Sampling error is the difference between a parameter and a corresponding statistic. Since in most cases you don't know the real population parameter, you can use inferential statistics to estimate these parameters in a way that takes sample error into account. There are two important types of estimates you can make about the population. One is the point estimates and the second is interval estimates. Confidence intervals are useful for estimating parameters because they take sampling error into account, while a point estimate gives you a precise value for the parameter you are interested in. A confidence intervals tell you the uncertainty of the point estimate. The goal of hypothesis testing is to compare population or assess relationships between variables using samples. Hypotheses or predictions are tested using statistical tests. Statistical tests also estimate sampling errors so that valid inferences can be made. Statistical tests come in three forms: tests of comparison, correlation, or regression. Comparison tests assess whether there are differences in means, medians, or rankings, or score of two or more groups. Correlation tests determine the extent to which two variables are associated, while regression tests demonstrate whether changes in predictor variables cause changes in an outcome variable. You can decide which regression test to use based on the number and types of variables you have as predictors and outcomes. To sum up, descriptive statistics allow you to describe a data set, while inferential statistics allow you to make inferences based on data set.
Difference between the population and the sample. When analyzing data, it is vital to know the difference between the two terms. What is population? It refers to the entire group of people, events, or things of interest that the researcher wishes to investigate. Another meaning of population. Group of people, events, or things of interest for which the researcher wants to make inferences. An example of a population would be the entire student body at school. It would contain all the students who study in that school at the time of data collection. Depending on the problem statement, data from each of these students is collected. This picture also shows the example of population. What is sample? Sample is a subset of the population. It comprises some members selected from it. In other words, some but not all elements of the population form the sample. Next is the example of a sample. Samples are used when the population is too large to collect data. The data collected is not reliable. The population is hypothetical and it is unlimited in size. As we can see, population and sample is different from each other. Population means entire group, while sample is also specific group. The following video shows the difference between the population and sample. The population is entire group, size is large, measurable quality is called a parameter. And a complete set. While the sample is a specific group, size is small, measurable quality is called a statistic subset of population. There are advantages and disadvantages of population and sample. Advantage of population. When the entire population is used to carry out the study, results could be more accurate. Advantage of sample. If sample is representative of the population, reliable estimates could be made with less time. Disadvantage of population. In most cases, it is impossible to test an entire population. A disadvantage of sample. If the sample selected is not representative of the population, the results are not satisfactory.
Let's get to know parameter versus statistic. They are both with the same meaning. They are a descriptive measure. Now, what is descriptive measure? Descriptive measure in statistics are referring to the average, mean, median, standard deviation. Sometimes you will be seeing percent and also proportions, in which you will be describing your population or the sample. Now, when you say parameter, this will be describing your population. So as you can see here, you got P on parameter and P on population. So it's easier for you to recognize whether this descriptive measure is parameter or statistic, because when it describes a population, you will have that one as parameter. When it describes a sample, then that will be statistics. So you will really have to remember this one easily, because you've got their first letters that are the same. So we have PP and SS. PP parameter, that's describing population. SS statistic, that will be describing your sample. So let's now have an example here. Let's try to determine whether the following is a parameter or a statistic. So we have the average annual salary for 35 of a company's 1,200 accountants is 3,400,000 pesos. So we are here to determine whether this is a parameter or a statistic. But first, let us try to find what is our descriptive measure. So that descriptive measure here is what we have asked the average annual salary, which is equivalent to your 3,400,000 pesos. So that's our descriptive measure. So now what does it describes to, or what is it describing? It's describing your 35 of a company's 1,200 accountants. This one now will be categorizing or identifying whether the one we are describing here with our descriptive measure is the population or sample. 35 of a company's 1,200 accountants, meaning to say you've got the one as only portion. Only a portion of the 1,200 companies accountant in there, so this is just a sample. Because when you say sample, that is just a portion taken from the population. And normally, when you say sample, you've got the keywords there are selected sample and then most likely sorted so that would somehow will give you a 90. Sure that you will have there a sample. So this time we have here a sample. Since we have a sample, this is now PPSS. Try to think if what that one PPSS. So we have our sample which starts or which started with the letter S. So automatic, this is descriptive measure which is the average annual salary which is 3,400,000 pesos is that we call as statistics. So I hope it's clear. So we go for another example. In a survey of a sample of high school students, 43% said that their mother has taught them the most about managing money. Now, as I mentioned a while ago, when you say descriptive, it may not be the mean, the average, the median, the standard deviation. It may be of the form percent or proportion. So on the statement, we have 43%. This is our descriptive measure, in which this will be describing our sample of high school students. So since there is the word sample on it, automatic there is our sample, and again, your descriptive measure, there will call that one as statistic because we are describing our sample which starts with a letter S, so I hope we are able to follow through. Next, we have 62 of the 97 passengers aboard the airship survived its explosion. Now, the first thing for you to do is to really spot or determine what is your descriptive measure. We don't have the mean, we don't have the median, the standard deviation in there. We don't have the percent, but what we only have here is our proportion, in which we have the one as 62 of the 97, so that is your proportion. 62 of the 97 passengers, so this will be our descriptive measure. Is it a parameter or a statistic? Now looking at what it describes, to this describes the passengers aboard the airship, and we are talking about the population in here, which is the subject of your study or the research, so that is your population. And of course, your 62 of the 97, in there we call that descriptive measure as a parameter. Next one, we have January 2021. 80% of the senators are in favor of the COVID vaccination. So this statement here, we have our descriptive measure as in terms of percent. Now, let us try to distinguish whether this descriptive measure is a parameter or a statistic. Let's look for the one it's describing. It's describing the senators. Now, if you have there a name that refers to the entire group, that is population. So the senators or any names there to represent one group of individual that will be taken as population, unless you have a specified number in there beside that name of a group or individuals them that will be taken as a sample. But since when we have the signatories there that is population, automatic 80% will become a parameter. Next example, we have the average height of the grade 11 senior high school students is 5 feet and 2 inches. So again, we have our descriptive measure which is the average height which is 5 feet and 2 inches. We are going to take that long with a descriptive measure because that's the value of the average height, and of course that's describing to the grade 11 senior high school students, in which that is taken as one group, and that's a population, so this is our parameter. Next example, we have the average height of the grade 11 senior high school students is 5 feet and 2 inches. So again, we have our descriptive measure, which is the average height, which is 5 feet and 2 inches. We are going to take that along with a descriptive measure because that's the value of the average height, and of course that's describing to the grade 11 senior high school students, in which this is taken as one group, and that's a population, so this is our parameter.
There are two general types of data, and these are the quantitative and qualitative, which are both equally important. You use both types to demonstrate effectiveness, importance, or value. What is a quantitative data? A quantitative data are measures of values or counts and are expressed as numbers. Quantitative data are about numeric variables, for example, how many, how much, or how often. And what is the qualitative data? Qualitative data are measures of types and may be represented by a name, symbol, or a number code. There are two types of qualitative data, namely nominal data and ordinal data. Nominal data, or a nominal group, is a group of objects or ideas that can be collectively grouped on the basis of a particular characteristics, a qualitative property. A variable that codes whether each one in a set of observations is in a particular nominal category is called categorical variable, while ordinal data classifies data while introducing an order or ranking. For instance, measuring economic status using the hierarchy, wealth, middle income, or poor. However, there is no clearly defined interval between these categories. Nominal provides the least amount of detail, while ordinal provides the next highest amount of detail, and interval and ratio provide most amount of detail. In a nominal level variable, values are grouped into categories that have no meaningful order. There are three types of quantitative data, which is the discrete, continuous, and interval. Discrete data is a numerical type of data that includes whole concrete numbers with specific and fixed data values determined by counting, while continuous data includes complex numbers and varying data values measured over a particular time interval. Interval data is measured along a numerical scale that has equal distances between adjacent values. These distances are called intervals. There is no true zero on an interval scale, which is what distinguishes it from a ratio scale. Quantitative is a quantity and qualitative is a quality. Data collected about a numeric variable will always be quantitative, and data collected about a categorical variable will always be qualitative. Therefore, you can identify the type of data prior to collection based on whether the variable is numeric or categorical. Next is, why are quantitative and qualitative data important? Quantitative and qualitative data provide different outcomes and are often used together to get a full picture of population. For example, if data are collected on annual income, that is quantitative. On occupational data, that is qualitative. Could also be gathered to get more detail on the average annual income for each type of occupation. Quantitative and qualitative data can be gathered from the same data unit depending on whether the variable of interest is numerical or categorical. And to move on, let's talk about the four main levels of measurement. Like I have mentioned from earlier, there are four types of levels of measurement: the nominal, which is a data that can only be categorized. The ordinal, a data that can be categorized and ranked. Interval, a data that can be categorized and ranked and evenly spaced. While ratio is a data that can be categorized, ranked, evenly spaced, and has a natural zero. Example of nominal data. Example of nominal scales include gender, marital status, college major, and blood type. Binary variables are a type of nominal data. This data can have only two values. Statisticians also refer to binary data as indicator variables and dichotomous data. For example, male or female, pass or fail, in the presence or absence of an attribute are all binary data. In nominal measurement, the numerical values just name the attribute uniquely. No ordering of the classes is implied. For example, jersey numbers in basketball are measures to the nominal level. Next is the example of ordinal data. Ordinal data these are the examples you can see in the screen. Are the academic grades like A, B, C, and so on. Happiness on a scale of 1 to 10. This is what's known as a Likert scale. The satisfaction, it is either extremely satisfied, quite satisfied, slightly dissatisfied, or extremely dissatisfied, and can also be income, the high, medium, or low. Next is the examples of interval data. So interval data is measured on an interval scale. A simple example of interval data is the difference between 100 degrees Fahrenheit and 90 degrees Fahrenheit is the same as 60 degrees Fahrenheit and 70 degrees Fahrenheit. And lastly, the examples of ratio. A ratio scale is the most informative scale as it tends to tell about the order and number of the object between the values of the scale. The most common example of a scale are height, money, age, weight, and etc.